Hello, everybody, and welcome to this class on interactive materials for gameplay, part of the Unreal Fellowship Games for 2024. Okay, there are project files which comes along with this course, which you can download and follow along with. There are a couple of exercises, but they're quite short and sweet, so nothing major. You can either just watch, but I will be primarily within the project. Now, in this project, we are going to be using something called the teaching aid. Now, if everything is working okay, when you fire up the project, it should automatically open up this widget. And the intention is for it to be in the top right-hand corner above the outline. Now, this is useful because you will be able to follow along with any of the classes by clicking back, forwards, in order to get to the same point. You'll be able to see the point that I'm at any point. Having said that, I will jump into the engine and we can see how this is working. So here is the teaching aid. I'm going to drag it and place it up here. I'm going to shrink it down. I'm going to close that down so you can see whichever slide I am at any one time. This will allow us to jump through the project, and it will also highlight any of the files that we are supposed to be using at any one time. Let's reset my filters. So you'll see as we move through the project, it will change to the relevant files that we're working with. So it's a nice little just convenience so that we can all be in the same place, especially when we've got something that's got lots and lots of different examples. So the course outcome for this, this is quite straightforward, this interactive class. What we are looking to do is we want to show you how to use materials and connect them interactively to gameplay. So when we're going to be looking at all of the different parts of materials, and the main things that I want you to go away from this is I'd like you to understand the parameters and how you can control materials, how to change these parameters at runtime, and the different types of effects that you can create. Okay, so that's the main thing. Apart from that, we're just going to be going throughout lots and lots of different examples. So let's start off. I'm going to go to the standard output nodes, which is number 1 on the teaching aids. What can you control? Well, you can control anything. So if you look at these examples, see if I can just get the lighting settings a bit better. So if you look at any of these examples, what we have here is just this. Well, always forget that. What we have here is a number of different. I'm just animating each one of the nodes on the standard outputs of the material draft. So you can see here we have textures, which I'm lerping between two different textures: base color, metallic, the specular, roughness, emissive, normal, opacity mask, and opacity. So the goal from this is you can just see that first, off the cuff, we can animate any of these. Now, they're animated in slightly different ways. Do feel free to open up the materials as you're going into them so that you can see how. So this is not in here, but I can. So, for example, I'm using a lerp on the sphere texture. So if I grab this texture, you can see that I'm doing an emissive color. Let me change this to a. Now, what I'm doing is I am using a MFUI linear time, and I'm ping-ponging between two values. and I'm lerping, so I could almost just increase that by 5. And then I'm clamping it to 1. The reason I'm doing this is just so that it stays at one of these values as it is. Now, the mf underscore UI linear time is actually a node which comes with the UI toolkit, which can be found on the marketplace. So I'll just find that for you so I can give you guys the link. But UI toolbox, I think it's called. Toolkit, maybe. What would be great is if you either of you, Emmanuel or Franco, if you can find the UI toolkit. It was released by Epic, but it gives a whole load of different nodes and stuff like that. However, if I wanted to imitate this, I'll find that as we're going on. If I wanted to imitate this, I could just use our standard time. So time is going to return system time as we're going through, and I can run it for a sine wave. Now, if you've not encountered a sine wave before, what time will do is if I put a value for a sine wave, so as I've got a left, might be hard to see, but any value that I put through a sine wave is going to do something that looks like this. So it's going to have +1 at the top and -1 at the bottom. So any value that I put in is going to give me some value between +1 and -1. And if I increase that value, we will go up and down this output. So that's why this is really useful if you want to get some kind of flipping between two values. If I don't have something like a node already created for it, what I will usually do is add 1 to it and then divide by 2. So that simple setup would give me a value between 0 and 1. And I could just plug that into any alpha and apply. And you'll see that it'll transition between 0 and 1. If I stick that into the emissive color, it's just going to go black and white. But this is a useful thing just to make things flash. If I wanted to speed up or slow this down, don't worry about copying along. I can just multiply the time value. I do 10. See, we get much higher flickering. 0.1, be much slower. Too slow almost. Okay, so what I'm looking for you to take away from that is that we can just use, and we're going to look at the inputs that we can use in order to animate or change a texture. And one of the ones that is quite important, one of the ones that's obvious to us is time. Time is consistently moving on, and we can use it in numerous ways to animate or change a texture as we're going, usually using the sine wave so that we keep it within an arc of values which are usable. Okay, so don't worry too much. You don't need to follow along with that. I'm just demonstrating. So the first thing that we have are the standard nodes. And these are all just in the same way animations of changing these nodes up and down. So you can visually see what happens when you animate those nodes. So all of these nodes are alterable by parameters. So any one, like we've done the example of lerping between two textures. However, we could use it to animate any other node. Okay, so next up, we have UVs. Now, I haven't necessarily animated these UVs. What I'm doing with these UVs is I'm attempting to show how the different UVs track, because we are going to be using the UVs as an input and a control on numerous different elements. So what we've got is we have our standard UV setup, and then that is the model's UVs. And how that works is we will have a UV, or we'll have a straight up UV, which is a texture map of an object telling us where, when we place a texture on something, where each pixel should be when wrapped over a 3D model. So you can see in this case, we've got the faces are just, it's overlapping. Each one of the faces have the whole UV. The second one we have here is screen space. Now, as you can see with screen space, we are actually ignoring the model's shape entirely, and we are mapping the texture to fit onto the screen. So I've equalized it out so that it shows as the correct dimensions, but that is showing on the screen rather than mapped to the object. Now, the next thing is world space. Now, what world space is doing is it is projecting in the different angles from in world space. So if I was to grab this and move this around, you would see that it ignores the location. So it's most easily seeable from above. So it ignores the location of the cube, and you can move so each one of those faces will stay in the same location in the world. It's just the cube will move. Now, it has some oddities when you're facing on the edges, as you can see here, because we are actually trying to triplane map this onto a model. So it has some weird oddities when you are halfway between the two of them, and it's not correctly mapping to a different axis. Now, the final one here is the object bounds. We're going to use this in a few times, because what this is going to do is when we have any mesh, when we have any mesh inside the world, a skeletal mesh or a normal mesh, it will have a sort of invisible cube that's placed around it, which is the object bounds. And the object bounds are they're used for a few things, but primarily it's used for frustum culling. So when the bounds are off the screen, off the frustum of where a camera is, it knows not to go away and render it. So if you ever see that you've got an object that gets close to the side of the screen and it starts blipping out, that's probably because your bounds are too small for what the object is. But it is useful if we want to work with something, and we'll demonstrate it quite early on, but at the moment, this material, I am projecting just one angle of the bounds. So you can see we cannot see it from above and we cannot see it from the sides. We can only see it from one angle. But we will work with the bounds. Now, if you want to look at the code, again, with any of these, you can just grab them open here and you can use them as examples. It's quite useful because we have setups such as, okay, so I'm using very heavily the UI toolkit in this one, but I can give you any of the code if you want it for how to do this specifically. Okay, so that is UVs. Now we can manipulate UVs. And again, this is something else that we can control. So we can manipulate the UVs to pan them, rotate them, or scale them. And this is useful for giving us effects like any of these. So you can see here, all of these animation effects are done just by manipulation of the UVs inside a material. So I will open one of these up, I think. I think the panner is probably the most obvious one. So I'm going to open up the panner. And you can see how simple this is. All I've done is I've grabbed a panner node and I have given it a speed value on just the y-axis, and I plugged it into the texture sample. So, and this so when we're looking at a texture sample, the UVs are going to be where we define the UV space. And so what we plug into here is going to be what we use to control the different UVs. Now, if you do not plug anything into it, it will default to the coordinates of the UV space of the mesh, because that is considered the default. Okay. So next up, we had something that's called a world position offset. And if you listen to me and Franco chatting before, this is the thing that this is the thing that it's like quite amazing to see that it kind of exists, really. But what we're doing in this is we are using the world position offset in order to move the placement of pixels. So we're giving when a pixel is rendered, when a specific pixel is rendered, it wants to know where in the world to render it, and we can move that, and we can add an offset to move that pixel around. Now, these are just 4 examples of using the world position offset as a method of animating Manny in this case. So we are using the squish, the sway, the rotate, and the shrink and grow. Now, there are a couple of things that I find useful to note here. The first thing is we're using the bounding box as a mask. And I'm going to go back and forth on the bounding box. But as you can see in this, his feet are kind of more black and his head is white. That's because we are using the bounding box as a value so that the changes in the world offset position are more prominent at the top, less prominent at the bottom. But this is a good example of how you can use the bounding box as a method to sort of like pin the feet to the floor, where you can make the top half of them wobble about. So let's have a quick look at one of these materials. Feel free to open up any of these materials. The other thing I'll note while we're here is you can see that with the rotate, we have some weirdness. And that's because this is done, we've moved the pixels, but we've already calculated the lighting for the pixels based on where it originally was. So that means with this, his shadow is on his back because it is the equivalent of the shadow that's on this guy's back here. I've even tried to stick a light in to try and correct for it, but it's not working. So just be aware of that. If you're doing rotation on a big scale, shadows can become a problem. Yeah. Okay, so let's have a look at one of these materials. I think probably let's do sway. Okay, so now again, we are just using the sine time wave to create the 0 to 1 effect that we had previously. And in this case, what it is going to do, as we can see on our thing here, is it will invert. So we're going to be timesing it, so we'll go in each direction. It might be easier to see with a cube. Now we're also using the bounding box here. Now, the bounding box you can get in numerous different ways. Again, if I was to, I can probably just open this up to show you. We've got the local object bounds, and we are grabbing the absolute world position to bring this over. But this is a material function. I'll show you where to get that at the end of it. But if I was to plug that directly into the base color, you would see, well, we're getting roughly the same thing, actually, to be honest, but just inverted. It's zero at the bottom and white at the top, meaning that the white at the top is going to be where the effect is most prominent. But here in world position offset is where we are making the changes. So, and here, I think we are defining the direction. So if I was to change that to 60, you'd see that it jumps crazy distance away. Because this is a parameters in world space. I'm not taking it up and down. So I made that 2, but say I did change this to 3, you'd see that it goes up and down in those 2 directions. So it's a nice kind of effect that's running off of just parameters that we want altered. Okay, so I'm just going to go through a couple more odds and sods. No, don't save that. And then we'll take some questions. So next up, methods of display. So we have, so we looked at what we can do with it when we placed something on a mesh. However, materials function work in everything in the engine. So the first thing is we have the surface material, which, as you can see, we just mapped something to a mesh. Next up, we have a decal. And if you see a decal, it is just a flat projected image against a wall. So it's great for things like graffiti, or it's often used for like putting detail onto pavements and stuff like that. Now, next up, we have something that's called a light function. So a light function is if you have something like a point light, we have the ability to add in a light function material. It has its own domain, but the main thing about it is it doesn't really have any color. It just projects in black and white because we are effectively putting out a mask over any of the lights that we've got. But you can see we can project a face against the wall here. Now, a light function is often used as a way of, for example, if you have a complicated light that's coming through a wall and you want to fake a ceiling fan or something, a light, they're good uses of adapting stuff to lights. They're very commonly used to imitate real light. So, say, for example, you have a spotlight. It's rare that it would just be a completely flat one. It will probably have something that will imitate the bulb that's in it. So a light function would often be used if you're doing ArcViz or something for to make the way the light is expressed look a lot more realistic than just a flat blanket light. Next thing is we have a widget. And this is a world space widget. And so the widget itself is created and exists within the world. So that looks a lot like that. And finally, here we have a screen space widget. But I think in order to see it, we need to jump into the game. Because it's a screen space widget, it is actually going to map it over everything that is in here, and it will place it onto the screen, even if the location is directly in front of it. So that is a screen space widget. Finally, we have the post process. So this is an example of post process, but what we are doing in this is we are placing, after we have done all of the calculations, all of the lighting, all of the mixing of the metallic and the roughness and everything like that to figure out what the scene needs to look like. After that, we are taking the G buffers, which are graphic buffers of the final output, and then we're doing something to it. So in this case, I've just put a couple of faces up in the middle of the screen. But so post-process happens after you've done everything else, and it functions in screen space. So it always functions in screen space. Having said that, there are tips and tricks of how you can make it abide by objects and stuff that are in the scene. But it's, post-process volume. And it can either be used for specific effects, it can be used for UI, or it can be used for like color correction or a bunch of other elements like that. Okay, so do we have any questions at that point? How are things looking in chat?
Everything good in chat, and I taken care of. The one thing I would say, Ed, is we both cannot manage to find the toolkit that you're using, and since you're using it a lot, do you have a link handy or anything that we can paste? I searched far and wide. It's fine if you don't have it handy, but we'll probably grab it in a break or something.
Yeah, I will definitely find it. I'll just have a quick search. Marketplace Epic.
Unless you're gonna prove me like a fool right now, I searched far and wide for it in the marketplace.
Yeah, I might have got the name wrong. It's it's a really good one. Man, I use this all the time. Wait a second. So you know what? It will be under one of these UI Material Lab. There you go. Okay. It's we are having an actual talk.
I got it, sir. Thank you.
Okay. Yeah, I got the name wrong. So I'll throw it up and if you throw it in chat that.
I got it. You're fine. Thank you.
All right. So yeah, I'll bring it up here. It looks like this. Now we're having a talk later on by the woman who wrote this, but there's some brilliant there are brilliant chats, but it's about using materials within user interfaces. But what's fabulous is she's written so many good material functions that just speed stuff up. So I highly recommend looking over this. The link will be in chat. But that's it. I thought it was Toolbox, but it's Material Lab. Yeah. We created it so it's free. It's an Epic learning facility. Okay, so those are the methods of display. In that case, let's jump on to some examples. My first example is this is my first example of using an input, because when you look at a material, the question is what's interesting in material is how can you get it to do something? How can you get it to react to gameplay? How can you tell it what to do? Now, and there are numerous different ways, and I'm going to go over a lot of them. But the first one that I'm going to show you is camera distance. And I'll just demonstrate this. So we have Quinn here. So for example, here I have a path. So you can see we have a path which is just using the material. We are using the distance from the camera in order to move these cubes together. So you can see the path just assembles as the camera gets close. And so this is just using two elements. This is using the world offset position to move it away when the camera is far away. And then when you get close, the camera moves, the world offset position moves it back to its original position. So you can see how this is a very simple, very, very cheap, requires no coding. All of it is done inside the material. Now, my second example uses exactly the same functionality. However, it works with a door. So as I approach a door, the door opens. I can pass through it. As I come back away, the door closes. So this is just a straight up example of using world position offset. It just moves those vertices over to the left and to the right as the camera gets closer to it, creating a kind of simplified sort of door effect. So yeah, it's really, really sort of straightforward. It's not that easy to make because it requires mask. This is more complicated because it requires different masks and it requires setting up the movement. And the other difficult element is these vertices have to go somewhere. So when I move there, we can't move the entire door out to the right, or it would appear out the right. We've got to hide it inside of the door. Okay, so let's have a quick look at these materials. So I'll start with, let's grab one of these. Stop. Let's grab one of these. And both the materials should be here, but floating steps. So if we have a look at the floating steps material, you can see that I've done literally nothing apart from functionality into the world position offset. And so I've got two settings here. I've got the lerp, which is I've got the lerp, which is 0. So world position offset 0 would return it to the location where it originally started. And if the alpha is 1, it's going to grab a random location in world space, and it will then rotate it a bit, and it will make it bob up and down. So you can see out of bopping up and down to make it so it moves it to a random position and it makes it bob up and down. So quite sort of straightforward. Now, this is where we're doing the control. We have the camera position and then we have the object position. So the camera position is the position of the camera, which is looking at the material, and the object position is the pivot point of the object we've placed into space. And then we're just getting a number that's the distance. And so I'm subtracting. So we've got like a safety area. And then I'm using a divide and clamping it. So this just allows us to move it in and out. So as you can see, all of these are bobbing up and down and floating, and they're all at a random angle in the distance until we get closer. And then it will lerp in to appear in front of us. So it's just an example of using the camera. This, however, is slightly more difficult. So you can see here that I'm using, okay, so this is more difficult. I'm using some reroute nodes because the world position offset is a bit more complicated. The problem is I need to use a mask in order to make the two sections go in different directions. So yeah, feel free to rip these apart. They're all meant as examples that you can just take and you can just play with. So yeah, so that's a door. Okay. Tell us if we have any questions, otherwise I'm going to go on to the next example, I think. Jump on. So we now do have an exercise here. Well, I think there might be a little bit of confusion. So what we have at this point is an example of, just going to see if this is all connected up. Okay, I don't think I'm going to run this as an exercise because it's already built, but let's go over how this works. So I think this already, so you don't even need to do this. All I want you to do is to grab the material, open a material instance, disconnect it, and under the settings, you will see that we have a fade amount setting. And if I increase the fade amount, you can see that our objects are going to disappear. The shadows are not, unfortunately. I think if I turn this into, it's all movable. But okay, so what I'm trying to demonstrate in this is I just want to show you how that we can use the same material and create a dissolving effect on the material. But the interesting thing about this is we are not working with the same UVs. We're not working with the same. I can add this material to anything. So if I drag in an extra cone, I can just place this material instance on it, and it will dissolve using exactly the same thing. So we have a sort of universal dissolve effect. And the reason that works is because, firstly, I'm using the bounding box again. So we know that every object has a cube that's around it, which is functioning as a bounding box. And we can reference this bounding box within a material. So at that point, we can use that as a means of creating a dissolve. So let us look at the material. Now, what I'm doing again is I've got the bounding box here, and red, green, and blue. If I was to plug them in, so example, if I was to plug red in, we're going to see that on one axis it goes from black to white. I plug green in, then on another axis it goes from black to white. If I was to plug blue in, it would go from bottom to top. If I wanted to invert the mask, all I need to use is our trusty 1-, and that would give me an opposite mask where it comes from the top to the bottom. But yeah, so this is our bounding box. If you want to explore it, just open it up and grab the details from it. But what we're doing is we have a bounding box from the so we're using the B. So the B is Z. So that's going to be from top to bottom. And what I'm doing is I'm subtracting a scalar parameter. And I'm using that, and I'm doing it in two ways. So the first way is, if I change that to 0.5, you can see that we have this glowing edge around the outside. That's because I'm using the if to see if it is more than 0, I think in this case. And then if it's more than 0, I'm going to put a large value into the emissive so that we get the glowing effect. Beneath that, what I'm doing is I'm checking if it is below 0.005 or if it's above 0.05. And if it is, I'm going to change the opacity. So we're creating this effect here just by we've got a 0.5, so 5% of the value is going to give us a glowy effect, and the rest of it is going to affect the. And the rest of it's just going to affect the straight opacity mask. So this is a really cheap effect. The glow gives away the point that we don't have a sort of, we don't need to use transparency. So if I was to look at this under the shader complexity, see it's mostly really, really cheap. It's less cheap if I've changed something to a movable, I think. Yeah. No, it's not much in it. And this is an important step to understand, because what a material instance does is it allows us a child of a material which we would be capable of playing around with the values to create an effect. And we will look at how to change this value in order to control this value programmatically. Cool. Do we have any questions?
We are good.
Okay. Okay, so let's jump on to the next exercise. Okay, so this is one that I'm actually going to ask you guys to follow along at this point. And this is, we're going to look at creating a dynamic material. Now, we've looked at a material instance and we know that we can control a scalar by, we can expose a value and then the material instance, it can be updated. All I want to do in this case is I want to use that value to control an effect. And in this case, I'm going to use a decal. So if I was to press Control P here and start. And then if you click on the screen, you should get an exploding effect. Now I want to beef this up a little bit. So I am going to play around with this effect. Okay, so hopefully everyone should get that, but this is, if you're doing the exercise, this is the point where we should be following along. So I'm going to kill that. Now, all this does at this point is when I click my mouse onto the screen, it will create a BP targeting. It will spawn a BP targeting. And if we look into the BP targeting, what it does is we have a begin play. It then explodes and then it waits 5 seconds and it destroys the emitter. Now, let's use a dynamic material before this. So let's do something with a dynamic material. So if you could please open up BP targeting. If you're using the training aid, you should be in the correct directory. If you are not, it is interactive materials exercise 2 decals for all of the stuff that we need. Now, first thing we're going to do is jump onto the construction script, because when we were looking at the material instance, we were looking at a whole load of meshes which all have the same material. So when I updated one material instance, they all updated at the same time. Now, if we want to programmatically control a material, we probably don't want all of them updating in the exact same way. So what we're going to do is we're going to create something called a dynamic material instance. So what that is we need to generate it programmatically. And that's going to be a material where we will be able to update any of the values on it, be scalar or vectors. We'll be able to update them dynamically. I think we can even do it with textures as well. So we can change them at runtime. But the first thing we're going to need to do is create that dynamic material. So on the construction script, I'm going to drag off and I'm going to type in create dynamic material instance. So you'll see this one down here. And all we need to do is select the count down timer. I think the timer material, or do we use, let's go with instance. The countdown timer instance. Now we are going to, we need a reference to this. Like with widgets and a lot of other things, if you create something and then don't create a reference to it, it's incredibly hard to find. So on the return value, I am going to promote this to a variable. And I'm going to call this, timer, apparently. It doesn't seem like the best name, but I'm going to call this dtimer_. D-timer mat. Okay, there you go. Dynamic timer material. Oh, there's already one down here. That's why. That's why I can't rename it. But yeah, we'll go with D-timer mat. And we'll see. Okay, now again, I've created this material, but I've only created it in memory. So it's of no use to us because we can't see it on anything. We need to set the material. And we want to use the decal for this. So I'm going to drag a reference of the decal in. You can see we have a decal as a component of this actor. I'll drag off of the decal and I'll type set decal material. I'll connect that up and I'll connect up the material like this. So I'm doing the three things that I want to do. I need to create the material in memory. Then I need to save a reference so that I'll be able to find it in future to reference it and save it to a variable. And then finally, I want to apply that material to this decal. Now I'm going to save and compile. I look in the viewport. I don't think I'm going to be able to see it because the decal requires a surface. But if I look on the level, I can see this here. So that's what our material looks like. Now we've got the material here, so we can have a look at it. And it's a little bit complicated, but what it's doing is it is creating circles heading towards the center. So it's sort of a targeting point. And again, we're using the lab for a couple of functions. But what's interesting is we have a scalar parameter here for progress. And we're using the same scalar parameter here. So the whole effect is being controlled by this progress function. Okay, so we need to update this progress value inside of our blueprint. So to do that, let's use a timeline. So I'm going to drag off from the begin play, and I'm going to type in timeline. Add a timeline. I'm not going to bother changing the name. Now, I don't want to run the explode on update, so I am going to drag that to the finished. So when we finish the timeline, it will explode and then it will destroy the actor. Okay, so yeah, we do have two. Oh, we have circle color. We do have two things. So in the timeline, actually, if we look at this, we should have one for circle color. Progress, glowing center. Yeah, circle color. We've also got a parameter for circle color. So these are the two parameters which we're going to try and control using a timeline. So if we jump into the timeline, we're going to need two tracks. The first track is a float track. I'm going to rename this to progress. The second track is a color track. And I am going to update this to be called color. Now, the length, I'm going to set to 3 seconds. So I want this effect to count down over 3 seconds. And over these 3 seconds, we're going for progress here. So I'm going to add in right-hand click, add a key at the beginning, scroll out and add a key at the end. And for the first key, I'm going to want to make the value 1. And the second key, the value should be 0. So you can see we have a progress which is going directly down like that. I've even moved it slightly below. I might do that again. Now, I don't think we've worked with a color track before this. We might not have worked with a color track before this point, but we have an above and a bottom. Now, the above is going to be the color, and the bottom is going to be the alpha. So the alpha is going to denote, it's often used for transparency, for example. But we're only really worried about the color. Now, I want to start at red. So if I left click, I'm going to change that to entirely red. So you see it'll start at red. Now, I want to end at white. So I'm going to drag the white over to the right-hand side. Actually, I'm going to drag the white to about here. And then I want to add another red in here. So I'll left-hand click, and that will give me another red. So what you can see is what we've got it red until we get to about the middle, and then it will start to convert to white. I'll leave that up for a minute. I'll save and compile. So with that done, I can jump back to my event graph. Now, we know that the update pin on the timeline is going to fire on tick. And we've got the values, the progress, and the color coming out of here. So if we drag in our D timer material and get this, we can set the values on this. So I'm going to drag off. And the first thing I'm going to do is a set scalar parameter value. And I will connect that up. And I will connect the value to progress. And I'm going to change the name to progress. So we are updating the material on progress. Now, next, I'm going to drag off, and I want to set a vector. Because we're working with a color, we're going to go with a vector at this point. And I'm going to drag that up, connect that to color, and change the text to circle color. Now, it's important that this is identical to what's in the material, or otherwise it will not work. Okay, so hopefully you have that done now. Don't worry, it's all in the notes with this, but it doesn't matter if you haven't got this working. But you can immediately see that we've got the material up here. So I'm going to delete that. And I'm now going to press play, go full screen. And you'll see we have a kind of effect where the material is dragging in, then exploding and changing color as it moves. Okay, so I'll bring up the code again just in case people need it. But is anyone having trouble getting that work? There's only a couple of exercises in this whole 2 hours, so and I think this is probably, we'll check to see if people are okay, and then we'll take a break for 5 minutes to give everybody some breathing room. How's it looking in chat?
Yeah, people are trying to follow up. A couple of questions there, but nothing we can't handle. Colin has don't have the target pin in the set vector parameter value. So he's missing the target pin. Yeah, you should probably, Jaime is answering here, probably trying to create it. Yeah, exactly that. Trying to create the set vector parameter value while dragging from the actual parameter. So it makes Unreal context sensitive, and it should create the node correctly.
Yeah, and my guess is that you are maybe setting on a material parameter collection or something else. If you don't drag off the material and use context sensitive, there's a lot of bits of the engine which use scalar parameters. So it could be anything. But yeah, if you drag off and you make sure you're looking for that, as long as you drag off, you know you'll always have the target pin because it's only going to give you stuff which can connect to that element.
Yeah, exactly that. I think we found the issue. Some people are setting a second scalar instead of switching to vector.
Yeah, second one's a vector because it's a color. It will plug directly in, but I just wanted to demonstrate changing colors and changing scalar values. There's some other you can change textures, I think, but actually I'm not even sure if you can anymore. Let's see, set scalar vector. You can change textures. You can change textures. Yeah, whole load of stuff, but yeah, hopefully you guys have it working. It should automatically change to this game mode once you've jumped to this spot in the project. So that's what it should look like. Okay, in that case, we are at halfway. So let's take a 5-minute break, everybody. We'll come back at 5 past and carry on from there. Again, that's the exercise entirely done. There might be another exercise, but all of the exercises are quite short in this, just because it's more here's a whole load of toys you can play with. Cool. Right, in that case, we will start again at 5 minutes past. So if anyone needs loo or anything, then do please do it now. I'll pause the recording for a second. Do remind me to turn this back on. Hello, everybody. I'm back. Let's get going. So, we finished that exercise, so hopefully everyone's had a chance to get that to work. Unless there's been any major problems in the chat, I will continue. Right. Overlay materials. So we had a little session where we talked a little bit about post-process materials and how much I love them. But let's go over sort of let's touch on them here and look about how they can be used. So the first thing is you don't necessarily need to carry along with this, but what I'm going to do is I'm going to go over creating and adding a post-process material to the world. Now, if I come in here, I can add a post-process volume. Well, there might even be one in there. Oh, I think there's already one in here. So let's get rid of that. So in this level, we have a post-process volume. Now, a post-process volume is locationally based. So at this point, this post-process volume will only do anything if I sit within it. Now, I have a number of different sort of cubes and stuff here. Now, if I wanted to draw an outline, so if something could be seen in an X-ray through a wall, I could do this using a post-process volume. And so in order to get this to work, oh, we already have one in here. Okay. So what does this do? Nothing. Okay, we're going to build one from scratch then by the looks of it. So creating a basic post-process volume to do an outline. Now, when we're working with the post-process volume, One of the main things that one of the main nodes that we have to use is, wait 1 second, post-process overlay. Yep. So one of the first things that we have to do is we have to make sure we're using the correct material domain. At the moment, we're using surface. The surface won't work because it is designed to work with meshes or skeletal meshes. So we're looking for a post-process material. So I'm going to change the surface to post-process, and you'll now see that we get this. And we are getting this because we have nothing plugged into our emissive color, which is our only non-grayed out output. And that's because post-process happens after all of the rest of the stuff. Roughness has already been done, metallic's already been done, base color. They've all been figured out for the scene, not the specific draw calls. So we have to plug something into the emissive color. And the node that we would usually be working with is something that's called a scene texture. So let me go to scene texture average. What the hell does that do? Anyway, sorry. Scene texture. And here you go. So we have a scene texture here. We're just going to plug that in, see what that does. It does nothing. Okay, I will figure that out later. Right, so a scene texture. Now this defaults to scene color. And if you plug in scene color, you're just going to get the error because we are not in the material domain surface. However, we have in the dropdown a whole load of extra options. Now, you'll see that we got stuff like roughness. And so roughness is going to give you the roughness value for everything that is within a scene. Now, we got the same for all of the other buffers. So we've got the diffuse, the specular, metallic, world normals, etc. and stuff like that. So world normals example, it's going to tell you the direction any of the surfaces are pointing in. And all of this is very useful stuff if you want to create a clever material. But the ones we're going to work with here is firstly post-process 0. Because post-process 0 is going to be the output of the rendering the scene. We've also got post-process 1, 2, 3, 4, 5, and 6 like that. My understanding is these are the outputs of is usually not used, but they're the separate post-process outputs in case you need them. So 0 is the one that we usually use. Now, if I want to create the outline, I need to somehow have a way of setting different models to register in the outline, but not something else. And for that, we've got, if I duplicate this, we have something that's called the depth buffer. Now, the depth buffer is really quite hard to see because it is so I'm going to show you the depth buffer to start with. So if I grab the depth buffer, search scene depth. Now, what the scene depth is, if I plugged this directly into the emissive color, we are just going to get a white scene. And the reason we're going to get a white scene is because the scene depth is measuring the centimeters away from the camera any of the surfaces that are hit. Now, standardly, your material will register a value between 0 and 1, with 0 being black and 1 being white. And then you use that, but you're usually working in values of 0 and 1. So when this comes up and it's in hundreds and thousands of centimeters, pretty much everything is always going to come up as white. So if I want to get some sensible value out of this, the first thing I'm going to need to do is divide. And for example, in this example, we're going to divide by 50,000. And let's see what that looks like. So 50,000 is probably too much. This is really hard to get right. Okay, so 5,000 seems like a good value. But you can now see that if I was to look at the scene from within here, you can now see that everything is coming up with black being close to us and white being far away. So this would be our standard depth buffer. And this is quite useful because like we used the black and white as a mask for the using the border, box, what do you call it, the bounds. We could use this in a post-process as a means for doing a lot of things, so like having an effect that's only far away. You can imitate a fog or something like that quite easily. However, that's not what we're going to do. We are going to jump back in. I'm going to swap this out, but rather than using the scene depth, I'm going to use the custom depth. Now, if I jump in, you can see that the circle and the cone are both the only things that are rendering. And that is because I have ticked on in this render in the custom depth pass. So I'll just search for that. So render in the custom depth pass. Okay, and so that means that I now have a way of creating an X-ray. So rather than it being the standard depth pass, it's a secondary depth pass which we can use for effects. Okay, so let's try and use it for an effect. Now, what I'm going to do is I'm going to use a lerp. And I am going to plug our standard out pin into the top. And I'm going to plug a color. So I'm going to hold down 4, I think. Plug that in here and make this a blue. So that's all right. We'll go with that for a blue. Okay, so we have a lerp now where it is going to give us halfway between the scene texture and halfway between the color blue. Now, I'm going to divide this by a really big number. So I've got a division by 50,000. I'm then going to use a 1 minus. You probably used a 1 minus before, but what this will do is it will invert the value from 1 to, so say you've got 0.1, it becomes 0.9. So you're going 1 minus the number that you had before. I'm then I've got to saturate then a clamp, but really they're doing exactly the same thing. So I'm just going to use a clamp. So if I use a saturate, all it's going to do is crop any values below 0 and over 1. If I do a clamp set like this, it's going to do exactly the same thing. But in this case, I want it to be 0.9. So what this is doing is if I was to plug that directly into the emissive color, you would see that we have created a mask. And if I plug that in and go apply, you will now see that we are showing an X-ray of those two meshes, the two that I've turned the custom depth pass on. Now there's one thing more that I'd like to do. If you watch it, it's a bit jittery. Now I can fix that by, if I go into overlay and I want to look at the blendable location. If I type in blend, there is blendable location. And if we do it after tone mapping, then there's going to be some jittering usually. So I try and do it scene color after depth of field. And then if I apply that, you'll find it gets a lot lighter, but also it gets a lot more solid. So you should see something that looks like that. Again, I will show that material. It's really quite simple. We're just using the custom depth as a mask, but in order to get a good value out of the custom depth, we need to play around with it a little bit. Okay, let's jump on to the next example. So, now that's quite straightforward. However, it isn't particularly pretty. This is a slightly prettier version. So if you jump to the advanced paper, you can see here what we have now. It's a little bit hard to see under this color. Maybe if I play around with the, yeah, a bit easier to see. What we've got is we've got a panning material which is going down, and we've got a bit of a solid outline outside. And the other interesting thing that we've got is if I place this behind this, you'll see that the object appears in front of it. Now, I will demonstrate this quickly, but what I'll do is I'm going to jump into I'll go into the material, and this is considerably more complicated. Okay, so I've commented it as much as I can, but each of these are doing separate. So sine wave moving stripes, which is in screen space. We've got an alpha based on the custom depth. We've got the tinting of the moving stripes. And here, which I think is one of the more interesting parts, is what we have is we're creating occlusion culling. We're effectively creating occlusion culling so that if something is in front of the material, it's going to test the custom depth and the scene depth. And if a value is in front of it, it's going to exclude that from the mask. So this creates an effect like occlusion culling, which is useful if you want to do an overlay of something that will appear behind things. Okay, so yeah, pick that apart, but if you want to, or just use the material as it is, the settings are all in there, but that's useful. Okay, so unless there are any questions, let's talk about overlay materials. Overlay materials are new, and they make a hell of a lot of stuff easier. So what an overlay material does is an overlay material will I'll sort of demonstrate it. So you can see here we have Manny, and he has these lines appearing and going up here. Now, Manny has two material slots. And if I wanted to create this material as part of Manny, it would be quite hard to implement because I'd need to find the base material. I'd need to write the material as the effect as something that you could switch on or switch off within the material, which then I would need to make sure they lined up and they were using something like the bounding box. So an effect like this would be quite hard to do within a normal material. However, what this is using, and if I select it and type overlay, you can see that I have a material here that's called an overlay material. And this material will work on anything. So we've got a couple of different ones here, but you can see that I've used the same material on both the box, the cube. I've used a slightly different one on the sphere, but it's just one single material. It takes up all material slots, and it would allow you to add an effect to a character. So how does, let's set one of these up. No, no, let's have a look at the ones we've got, to be honest. So the first thing is, so there are a couple of elements. This is really quite simple. We've got a checkered mask, which we are panning over with an opacity mask. And we're panning it over the character. Now, the opacity mask is important because the material is going to be over the entire character. So if you want to see the material that's below it, you really need to use something like translucent or transparent, or you need to use something like an opacity mask so you can show other parts. The other thing that's important is the world position offset. So one of the problems with an overlay material is that it is in the exact same pixels as the other material. So if you don't affect the world position offset, then you're going to get vertex, sort of the materials are going to clash and fight. So I'll try, if I disconnect this, let's see if we can see that happening. You can see it disappears. And this is what will throw a lot of people when they're using overlay materials. This is the really important thing. It hasn't actually disappeared. It's just it's below the mesh that's already there. So the first thing you want to do with an overlay material is this little bit of code. And all this is doing is it's grabbing the vertex normals of every face of every vertex, and it's pushing it slightly out. So like 0.2 of a centimeter, it's moving it out. And that is going to mean that you're going to be able to see it. So suddenly it's outside, so you'll be able to see it over what you're already working with. Otherwise, you would need to, you could use on the standard material, you could make, you could you could move stuff. What do you call it? You could make holes in the standard material to show the underneath. But that is an overlay material. Now, this material is slightly different because it's non-depth tested. So I think this is worth mentioning, because if you're looking to create something like we previously done in the post-process volume, we created an effect that can be seen through walls. It's so much quicker and so much easier to do it with an overlay material. But in order to achieve that effect where it can be seen through walls, there's a couple of things that you need to do. First thing is you need to make it translucent. And the reason we need to make it translucent is because this will allow us to disable the depth test. If I don't, you'll see if I don't have the depth test, if I have the depth test on, we cannot see it through something. But if I disable the depth test and apply, we can see it through stuff. So again, much quicker way to create a material, a sort of X-ray material on an object. Yeah, so that's how you make it. It can be multiple domains. It just needs to be in the overlay material slot. Now so this is us building one. So I think I've described it enough. How we do. I'm gonna skip over the building of this because I think we've gone through the description enough. However, what I will do is demonstrate what is possible with an overlay material. So if you come to this one and just press play, you're going to see that you get Mania. Now, if you walk up to any of these, it will apply an overlay material. So this is an example of an outline. And what this is doing is it's just a material where we're pushing it away from a camera and then expanding it so that it creates an outline around Quinn. This is a force field-like effect. So again, it's working on the same functionality, but all it's doing is we are just displaying a material that's got emissive, again, over Quinn. This is a sort of janky sort of electrocution effect. This is fire type effect. Not perfect, that needs some more work. A sort of ice-like effect. And a sort of tar-esque effect. So there's a lot of people making these online and stuff like that, but what's lovely is how easy it is to apply. So you can see at this point, I'm programmatically, and I'll open up the program, but I'm programmatically just applying a overlay material to a character, and then that is sort of existing, and that's just creating the effect, and it'll stay on there until we unapply. And the nodes are incredibly simple. So if we have a look at the nodes, Control E. So you can see here, what I have is a very simple mesh with a sphere collision. Can't see the sphere collision, but and when you overlap with the sphere collision, it is seeing, is it the third person character? If it is, set a overlay material. I'm also setting it in custom depth, but that's not for this. This is, if there's an overlay material, I'm going to set the overlay material. Yeah, so that is overlay materials. I think they're a great new combination. They're a brilliant way they can be used in conjunction with so many things. I'll often use them as a dissolve effect. So what I will do is I will dissolve up an overlay material and then hide the material below and then dissolve down an overlay material. So it makes something which will cover the character, then uncover it and it will disappear. So lots of other sort of effects that you can create with that. Are there any questions at that point? How are we doing? How far through? We've done that. We've done this. Do we have are there any other questions in there at the moment? We're doing pretty well for time.
We're doing good.
Pardon? We're all good.
We're doing good.
Oh.
Lecture chat is clean right now.
Sweet. Okay. Well, we've got people here. Okay, so let's jump on to the next example. So this is a machine. And this machine is using, I'm combining and I'm using a lot of the different examples that we talked about within the different elements. So all of this is done in materials. I think that's sort of important. None of this is controlled by blueprints or coding at all. It is all material based. So you can see we've got bubbling sort of water here. We've got pulsating pipes. We got a spinning generator. We got a couple of these, and these things are again just using world position offset to get a section of it to bob up and down. And so this is all controlled in materials. Now, this allows me to show you something called a material parameter collection. Now, I'll kill all these down quickly. Sorry, I'm just... Sorry, I'm just cleaning it out so that we don't have to look at any of this. So there is some coding, and we do have a small exercise which is connected to this, but we have a material parameter collection here. Now, what a material parameter collection does is it acts as a global store for a parameter value which can be added to a so you know that in an instance we can have scalar parameters. Now, what a material parameter collection will do is it will work as a global store for those parameters. And then those parameters can be edited programmatically, but they can also be referenced in lots of different materials. For example, here we have a vector parameter for color. Now, if I was to change this color to yellow, you would see that this changes to yellow, this cube changes to yellow, these things change to yellow. So all of these different materials, even though they're working in different places, they're all accessing and using the same parameter collection. And you'll see here that I've also got some scalar, I've got a couple of scalar parameters, one actually, and that's speed. So if I was to reduce the speed down, you'd see that everything slows down. We've also got, like, if I reduce it to zero, that stops entirely. We got none of the crackling. So if I look at this, for example, if I change that to about 0.4, you'll see that it'll start going through. If I change it to 1, now if I change it to 2, you'll start seeing we get little lightning crackles that go between them. So and then if I change it to, let's try 5, you'll see it become even brighter and the crackles get stronger. And so we've got this lightning effect. So what I'm trying to show here is that we have numerous meshes, numerous materials, which are all referencing the scalar parameter here. So imagine in a game you had like the turning off of a machine. So once you turned off the machine, not only did all the pipes stop pulsating and all of the water stopped fuzzing, but all of the machinery stopped moving. So you can connect up one singular value to tons and tons of different materials and have them like turn on and off at any point, sort of accordingly. Or you could change the color so that it flashes between red and green or something like that, so that it denotes the place falling apart. So I'll change that back down to, I'll change that to 0. Okay, or let's change it to 1. Now, so let's have a look at one of these. So I'll grab this section here and let's have a look at the material that's on this. Now, it's a hot mess. I do apologize. But what we have is speed here, and speed is multiplying the time, and it's controlling the rotation speed, and it's also, we've got color, which is controlling a bunch of the different colors, and speed again is used here in order to control the multiplication of the emissive color. So as the speed gets faster, the generator gets brighter as it's generating more elements. So, and also we have the color here, which is effective. Or if we've got a more simple example, if I was to select this cube and select the cube itself, you can see all we have on this cube is the parameter collection for color, just plugged into the base color. So I have a singular color, but it's being updated. So let's look at how we can programmatically change these values. So if you push play, you should get something that looks like this. Now, we have a bunch of buttons and a power slider, and none of them do anything at this point. However, this is the final exercise. What I would like to do is I would like to show you how we can update the parameter collection. So the first thing I'll do is I'll show you how to add a parameter collection into a material. So say I can come in here and I can go, if I type in collection, I usually type collection. And so as soon as I type in collection, I would get collection parameter. And at that point, I just need to select the correct parameter collection. In this case, it was, I think it's example. And I could select speed, for example. I could plug that into roughness. Now, the faster I make something, I might do a 1-. You don't have to follow along with this bit, but the faster I make something, the rougher I would make it. So all I've done is I've got the color exactly the same way as I've done color, but this time I'm using it for speed, using it in the roughness. So we would find now with our material, it's a little hard to see, but it gets rougher and it gets things. It's really hard to see actually. What I'll do maybe is I'll use that as a multiplier in the emissive. So I'll do multiply, plug that into the emissive and plug the speed in there. Yeah, so now that's probably too bright. I think I've set the speed too high. Things are gone crazy. No one do it. I'm gonna. So I just want to demonstrate how. So I'm gonna multiply that again just so that we can get the effect thing, and I'll do it by 5. Sorry, that's not so much part of the thing. I just wanted to give you an example of how you would add a material parameter collection into a material. So let's do the actual part of the exercise. Now, what I would like to do is if you guys, we've got the parameter collection, we're going to do the work inside this widget. So if you double click on the widget, open it up, you can see that we have these settings here. Now, these are buttons and this is the power slider. So let's work with the power slider to start with. So if we grab the power slider, move down, and we have an option for on value changed. And if you select that, it should take you to this element here. Now, what I would like to do is drag off and go set scalar parameter value. So you can see that we have under materials, we have set scalar parameter value. And this might be the one that you accidentally used last time, somebody accidentally used, but we can access this directly in here. Now we need to have the collection as example. So I'll just type in example. And now we can do a drop down. So we're going to work with speed. And I'm going to plug the value directly into the parameter value. So all I'm doing is updating this scalar parameter value, and I'm using the value on the on the slider to denote it. Actually, I'm going to times it by 6 because it gives me a value between 0 and 1. Let's times it by 6 so that we can get some good speed out. Now, under this, we have the red button. I'm going to drag off of this, and I'm going to go set vector parameter value. Again, it's the one under materials. It's the set vector parameter value. And again, I need to select the example control pack. And this time I'm going to change color. Now, we have a parameter value for the color. I'm going to drag off and I'm going to search for make color. And that's going to give me the values. Now, we're on the red button. So I'm going to do a 1 into red. Now, below this, we have the blue button. So I'm going to grab this, duplicate it with Control D, plug that in, and change it to 1 in blue. So you can see how simple this is in order to update parameter collection. So next up, we've got 2 more buttons. Let's just do the green and the yellow button. So again, I'm going to copy this section. Plug them both in. In green is easy. It's just 1 in green. And yellow, I keep forgetting. What's yellow? Yellow is... I'll just double check.
Green and blue.
Green and blue. Yes. Okay. So green and blue is yellow. Thank you for that. So hopefully you've got all of these set up. And that is all the code we need at this point. So if I compile and save... now, if I run, what we'll find is as I increase the power, everything that's attached to the power increases as well. And as I change the color updates in all of them at the same time. So we can control this scene purely off of updating the material parameter collections. What you can also do is you can read a material parameter collection into a code. So theoretically, if you wanted to set code off of a material parameter collection, you could do exactly the same thing. You'll also see that we have a little dial here. And this dial is connected to the power. So again, this is a material. It's purely a material, but this time it is a UI material. So, and I'm changing the rotation of this UI by using the power dial. So I think blue is probably the most effective. So it's just another example of how powerful material parameter collections are, because you can set one value, it can reflect in your HUD, it can reflect in the movement of things in the world, and then you could also read it in other places. So it is a really useful sort of global parameter to use. You could also do it in post-process volume as well. You could access it in the post-process to control how different things work. So it's just a nice overarching. The only problem with it is you can note that if I move this, you can see that any of the world position offset stuff is jittering. So that's not ideal. So I mean, conventionally, you'd probably do a lot of this stuff in blueprints. So you can see because it's calculating it as a percentage of time. It doesn't know what the previous frame was doing. So there's no way that you can make that smoothly move. As soon as you change the speed, it's going to jump to a completely different position.
Edward, don't touch the yellow button, please.
Why? You just what's wrong with it? Is it just burnt? Actually, the yellow button's green. Ah, you got it wrong. So what is yellow?
It's red and green.
Yeah. Yeah, that does. That makes more sense. So, yeah. So I'll just run that again and test the yellows. What? Yellow is now pink. What have I done wrong there? Red. Yeah, red and blue. That's right.
Oh, I was right in the first place.
So red and green. Yeah, there you go. Compile, play, yellow. Yeah. Okay. So has everyone managed to get that to work? It really is. Is there any queries? So that is we're finishing a good 10 minutes early, but if there aren't any questions, that is the interactive materials. We'll have a lab for an hour afterwards. But my hope is you now have a good idea of if you want to create a material and you want to use it as part of an effect or within a game, you should have a good idea at least of kind of how to approach that. There are different elements that I can talk through the build of each of these materials if you find it useful. Yeah, so cool. Right.
We do have one question, Ed. Pietro here asks, where do you set the UI material of the dial that you have on the top right?
Okay, so I'm going to jump into I'll jump into here. So you can see we have this widget for the power, and under brush, we have an image, and I'm using a material for that image. And if I jump in, I can fire that up, and you can see that this is how I've put together this material. But again, it's grabbing from a material parameter collection, speed here. And that's going to change the revamp value of how this maps across. So the material domain is a user interface and it's masked. So yeah, again, that's just under the appearance. It's an image. We're using a brush, and for an image, we're using a material. Okay, right. In that case, I will stop sharing. And we have almost 10 minutes. So unless there are other pressing questions, everything else we can look at in the lab. And we can go from there. Thanks again, everyone. I hope that you could follow that okay. Great. Bye.